There are three main ways of finding zeros in a quadratic. You can, 1, use the factoring method, 2, you can complete the square, and 3, you could use the quadratic formula. The reason why there's three ways of finding essentially the same thing, the zeros of a quadratic, is because the scenario could differ. There could be 1 0, there could be 2 0, and there could just be 0 zeros. Alright, speaking of zeros, I'm going to briefly describe what a zero is. This basically means that any time in the quadratic where there is a point directly on the x-axis and the height of the point is basically nothing. Alright, so I'm going to show to you the quadratic formula, which is the main focus of this video. Alright, so ax squared plus bx plus c is equal to 0. This is standard form of a quadratic, right? Standard form of a quadratic. And the quadratic formula is negative b plus or minus, because the scenario in which there could be two x values, there could be 1. The scenario can definitely differ, so plus or minus is that's why it's there. Plus or minus the square root of b squared minus 4ac, all divided by 2a. Alright, so this quadratic formula came from the standard form, but going from the standard form to the quadratic formula, it might get you a little confused. Basically, going from the standard form to the quadratic formula is just completing the square. So once you complete the square of the standard form, so completing the square over here, complete the square, you get the quadratic formula. All right. An example of zeros in different scenarios is right here. As you can see, the red graph, the red quadratic is x squared plus 5x. As you can see, there is there's two zeros right here. There's a negative 5 as a 0 and then a 0 as a 0. The blue graph is a really common graph. It's x squared. The only 0 for x squared is just 0, and there's another graph. It's x squared plus 2. It's just the normal blue graph, just shifted 2 units up, and there is no zeros on the black graph. So as you can see right here, you could have 2 zeros on the red graph. An example, you could have 1 0 as in the blue graph, and you can have 0 zeros as in the black graph. All right, so example, x squared plus 4x minus 21 is equal to 0. Alright, so you may be wondering how can you go from this quadratic into already just solving for x right away. Okay, the first thing you need to do is find out what a, b, and c is in your quadratic. Alright, so from remembering the original standard form, you can remember that ax squared plus bx plus c is equal to 0. So now you have to basically just know which coefficient on each term is the a, b, or c. So the a is the leading coefficient, which is the term ahead of x squared. So x squared is just x squared, so we know that the a is 1. B, as you can see, is 4, and c is negative 21. So now that you know your a, b, and c, you can now substitute it into the quadratic formula. All right, so now you have x is equal to negative b is negative 4 plus or minus the square root of b squared, which is 16. 4 squared is 16, minus 4 times a, which is 1, times c, which is negative 21. Alright, all divided by 2 times a, which is 2 times 1, is just 2. Alright, so now that you know that, we could continue on and slowly simplify until we get our answer. Negative 4 plus or minus the square root of 16. You got a calculator for this. 16 minus 4 16 minus 4 times 21. So I'm going to do 4 times 21. It is negative 4 times negative 21, so the integers cancel out. So 4 times 21 is 84, and you do 6 plus 16, so it's going to give you 100. All divided by 2. So you're going to get negative 4 plus or minus the square root of 100 is 10 over 2. As you can see right here, the only thing you could do from here is you have two possibilities for x. So I'm going to get rid of this to clear up some space. I'm going to do x1 in a different color. So x1 right here. x1 is equal to negative 4 plus 10 over 2. And the other scenario of x2 is going to be minus 10. Just right here. So instead of doing plus 10, you're going to do minus 10 for the other scenario to see both the zeros that you could get. Alright, so minus 4 plus 10 is going to give you 6. 6 over 2 is going to give you 3. So x1 is equal to 3. x1 is equal to 3. Use a different color. x2 is equal to negative 4 minus 10 over 2. That's going to give you negative 4 minus 10 is going to give you negative 14 over 2. That's going to give you negative 7. So x2 is equal to negative 7. Negative 7. Alright, so after applying the quadratic formula and finding the x values, it could be 2, it could be 1, and it could be 0. You could write a concluding sentence. You could say the solution to the quadratic is that the zeros are x is equal to 3 and x is equal to negative 7. This states that after we use the quadratic formula, we now know that the zeros are negative 7 and 3. Hope you enjoyed. This is some brief information about the quadratic formula, where it originated from, which is just going through ax squared plus bx plus c, which is standard form. From standard form, you complete the square. So going from standard form, you complete the square into the quadratic formula. And rough example on how to apply the quadratic formula. Something you should note is that zeros are very important because these are any moment in a graph. Let's draw a quick example real quick. Any moment in a graph where the y is equal to 0. So an example right here. There is no y value here and there's no y value there. So that means that the y value is 0 there. It could be, let's just say this is negative 4. It could be negative 4, 0. And zeros are very important because it is the solution to the quadratic. By using the 3 main methods I told you about before, you could use factoring. That's one. You could use completing the square, and you could use quadratic formula, which I just showed you.